All right, example 5, a snowball. All right, snowball melts so its surface area decreases. You guys caught me on that in class at a rate of 2 centimeters cubed per minute. So surface area, area should be squared. Surface area should be squared. So its surface area decreases. So I'm going to say d SA dt, or we could just say SA prime, and that equals -2 because it's decreasing, which makes sense if you think about a melting snowball, how it's a sphere getting smaller and smaller and smaller. It's totally a sphere, okay? So yeah, this again gets down to like, if we were to think about a real snowball, it would have like imprints from your hand and have like bumps and stuff, but that makes it more complicated, so we're keeping it simple. So find the rate at which the diameter changes. So I'm gonna say that's d prime when d is equal to 10. So here is the algebraic trick that we need to be careful of with this one. So the surface area of a sphere is equal to 4 pi r squared. I didn't expect that you knew that before this class, but now this is going to be common knowledge, and I'm going to expect that you know that. And I just like to remember that the surface area of a sphere is just 4 circles. That's how I remember it. So if I take this derivative, the problem is it's going to be r and it's going to be r prime, and it wants d and it has d prime, and so there's this kind of disconnect of how do I get this and this to kind of work together. And so I can relate that by going, well, I know d is equal to 2r. That's a fact that we know. And so what I could do is, instead of writing r, well, if I solve this, I could write d over 2 is equal to r. And so I could say SA is equal to 4 pi d over 2 squared. And I could do the problem this way. The other option is I could do the problem with the radius, and at the very end do some substitutions over here. So I'm going to do it this way first, and then I'll go and handle it that way. I did not do this way in class, so this is the other way. Now before I finish, I'm just going to 4 pi d squared over, now careful, both of those get squared, so d squared over 4, and then bink, bink. So surface area is actually pi d squared. So if I take the derivative, SA prime is equal to 2 pi d prime. And so now I can solve this for d prime by dividing by 2 pi d. So SA prime over 2 pi d is equal to d prime. So I know that's -2, I know that's 2, I know that's pi, and that was 10. So bink, bink, I get d prime is -1 over 10 pi. Now, if I'm going to type that in to find that, you need to be very, very careful that the pi does not wind up on the outside. So right now, this is doing it wrong. This is doing -1 divided by 10. You get that, then you do times pi. That's not what this says. This says take -1 and divide that by 10 pi. So make sure you use your parentheses appropriately. And you get -0.032 centimeters per minute. So the alternate method would be taking this derivative here. We'd get SA prime is equal to 8 pi r prime. And I could solve this for r prime. So SA prime over 8 pi r is equal to r prime. And then I can go and do some substitutions. If I take this derivative here, I get d prime over 2 is equal to r prime. I can go back and plug in SA prime over 8 pi. Oh, and if the diameter is 10, If diameter is 10, then that means the radius is 5. And so if this is my r prime, then I could just take this times 2. And get my d prime. So that's that.